only one inequality. This one inequality related the sides of the triangle. Like this inequality tells you if the given three numbers of the sides, like say I'm giving you three sides, one of them is 2 centimeters, another one is also 2 centimeters, the third side is 5 centimeters. Can we draw a triangle with these three dimensions? Let's think about it. I'm going to start from the highest number, the longest side, which is 5 centimeters. So do you think if I draw 5 centimeters in here, like this, say that's 5. Now to draw the triangle, I need to do the other two sides. The length of each of the two sides is 2. So if I make this is 2 and I make this is 2, do you think I can close the triangle if this is 2 and this is 2? But 2 plus 2, like they can cover only 4, but this one is 5 centimeters. How 2 plus 2, which is only 4 centimeters, are going to cover 5 centimeters? So actually with these dimensions, 2, 2, 5, we can't construct a triangle, we can't draw a triangle. So not any three numbers as length of the sides we can use to draw a triangle. So there should be certain inequality has to be satisfied first. If it is satisfied, then we can say we can draw the triangle. What I'm talking about is this. The sum of these two sides has to be more than this one side by itself. That's what we call the triangle inequality. So if I have a triangle ABC, the sum of any two sides of this triangle has to be greater than the third side. A, B, C. If you go straight from B and C, of course that's shorter than going around the triangle, going BA, then go from A to C. If I go from B to A, then from A to C, that has to be longer than BC directly. So this is what we call inequality of triangle, or triangle inequality. So the triangle inequality states that the sum of any two sides, sum of any two sides is greater than the third side. So on this triangle, if I'm doing AB plus BC, the sum of these two sides, AB plus BC, has to be greater than the third side. So that's greater than AC. If I say AB plus AC, AB plus AC, the sum of these two sides, it has to be greater than the third side. Otherwise, we cannot create the triangle. You understand? Hopefully. Then I can write the third one, like I did add AB and BC. One time I added AB and AC. I can also write the third inequality using AC and CB. So if I write down AC plus CB, this has to be greater than AC plus CB should be greater than the third side, AB. So if they give me three numbers like 2, 2, 5, and I want to check if these three numbers can form a triangle or not, I add the two smaller sides. If the sum is more than the third side, I can draw the triangle. If the sum of the smaller two sides is less than the third side, then we cannot draw this triangle. Okay, now we have another inequality. We're going to write it down. When I wrote the inequality on the previous example, we said that the sum of any two sides has to be greater than the third side. Meaning, or I can restate that statement saying that any one side by itself has to be less than the other two sides. So one more time, if I have triangle ABC, here is triangle ABC. A, B, C. Any one side by itself, like AB, it has to be less than the sum of the other two sides. If I'm talking about AB, it has to be less than AC plus CB. Less than AC plus CB. But I can't make that too small, because if I make it too small, this side is, when I make it so small and then I add it to another side, it's not going to be greater than the third side maybe. So now it's not only AB is less than AC plus CB, it has to be also greater than the difference between the other two sides. So if I'm assuming that BC is greater than AC, then AB has to be greater than the difference between BC and AC. BC plus AC. This triangle, or I mean this inequality, give you the range of any one side by itself. So I'm going to show you that in example right now. Example. In this example, it's here in the book. I'm just going to copy it from the book. They said that you are given an 18-inch piece of wire. You want to bend the wire. So I have a piece of wire, 18 inches. I want to bend this wire to make it look like a triangle. So I'm going to just bend it to look like a triangle. Say after I bend it and look like a triangle, I'm going to call it A, B, C. Alright, what's the question? We have a piece 18-inch long. I can just bend it any way to make a triangle. They didn't specify any particular measurement for these sides. Let's keep reading from here. Such that each side is a whole number. So we're not going to use decimals like this. This side, for example, could be 5. This side could be 7. So if I say 5, this is 5 and this is 7. So right now I'm using 12 out of the 18. So the third side has to be 6. Then I need to check if that works or not. But let's see what the question is. The question is a sketch four possible isosceles triangles and label each side length. So I have 18-inch wire. I want to form over here according